Okay, now this is a new topic, electronegativity. So we'll talk about the electronegativity, but before that, electronegativity and bond polarity. Yesterday I told you I've made a graph for you actually, which was between 0 and 4, and I told you that it's based on the difference of electronegativity between the two elements. So let me draw that line once again. If you're bringing two atoms close to each other, their electronegativity difference is going to tell us whether the bond is going to be ionic or covalent. Electronegativity difference, okay, DIFF. So from 0 to 4, and 1.7 is the middle point actually. Plus. इसको करना, सुल्तान को अभी करना, अभी तो क्लास है मेरी, थोड़ी देर। मेरा एसी घर का नहीं चालू, उसमें एसी ये खराब है। चलो ठीक है, मैं करता हूँ कि थोड़ी देर में। Okay, so if the difference is 1.7, then it will have 50%. The characters are 50% ionic. We can call it 50-50. On this side 100% ionic, on this side 100% covalent. I told you there is no 100% ionic, there is no possibility for 100%, but 100% covalent is possible. For example, F2 is 100% covalent, and the reason for that is that if we subtract 4, which is the electronegativity of fluorine, 4 minus 4 will result in 0. So any Cl2, O2, Br2, okay, H2, they are all 100% covalent. But there is no difference which is 4, because when you are subtracting, the maximum value is 4 and the minimum value is 0.7. So there is no element in the periodic table which is having electronegativity difference of, or electronegativity value of 0 actually. Because what is electronegativity? Now let us see. Electronegativity is the ability of an atom to attract the bonding pair of electrons towards its nucleus. Is there any element in the periodic table that will not attract the electrons? No. Every element has a nucleus. Even hydrogen is having a tiny nucleus with a plus charge on it. It's also attracting the electrons. Okay. So we cannot avoid this factor. So electronegativity, when we are talking about the electronegativity, let me zoom in a little bit. Electronegativity is basically classified, the electronegativity of element in general decreases down a group of the periodic table, that is from top to bottom. Yani every element, every group, top to bottom, there will be decrease. But when you move across, the non-metals, especially the halogens, they are highly electronegative. So there's an increase and there's a decrease. This is across the period, the first one, and this one is down the group. Okay, so that's what we have for the electronegativity. Now, every element of the periodic table is having this capability, and this is an arbitrary value. Arbitrary value, we mean to say that the first value is assumed that, okay, let's assume that this is having a value of 4. Like fluorine has been given a maximum value, and then after that the comparison is made between fluorine and the other elements. So if you look into the periodic table, you find fluorine, chlorine, bromine, iodine, and astatine, they're having the maximum electronegativity values, right? Then the second group is oxygen family. The minimum value which I can see in the periodic table is for cesium. Okay, so if I take fluorine to be cesium fluoride and I calculate the value for that, and I want to see that, okay, am I getting a value of 4 or not? If I get a value of 4, then definitely it's 100% ionic. If I'm getting value more or less than 4, then it's polarized ionic. Okay, so cesium is 0.7, so 4 minus 0.7, what is the result? I'm getting a result of 3.3. So 3.3 is not 4. That is the maximum we can do for it. So that's why this result is telling us that it has percentage ionic character. Okay. Now these electronegativity differences are given somewhere in your book here. Let me, if I can see. See, these are now the electronegativity differences. Let me clear this. This is already in the book. Okay. See the difference. Approximate if the electronegativity difference is 3.3, this is 3.3, focus on this area. How much is the percentage ionic or percentage covalent character? This is a percentage ionic character. It's 92% ionic and 8% covalent. So there is no element in the periodic table which is 100% ionic in nature. Are we clear with this?
Yes, sir.
Okay. I'm going to just stop here and wait for your questions. If you have any question, you can ask.